Okay, let's dive in. Imagine this. Way back, maybe 41,000 years ago, the Earth's magnetic field kind of went a bit haywire. The North Pole drifted right over Europe.
Yeah, it sounds pretty wild, doesn't it?
Totally. And that's exactly what we're getting into today.
And what's really interesting, especially looking at the University of Michigan study you sent over, is how this wasn't just some, geographical oddity. This event, the Laschamps excursion, seems like it had real consequences for the people around then, Homo sapiens and Neanderthals.
Exactly. So for this deep dive, the material you shared, particularly that Science Advances study, is basically our roadmap. We're trying to figure out how these big shifts in the magnetic field and the extrasolar radiation that came with it might have played a role in who survived, who spread out.
Hmm.
And here's a thought right up front. Maybe really simple tech, things like, I don't know, prehistoric sunscreen and just better clothes, maybe they're way more important than we think.
That's precisely the angle. So let's break down this Laschamps excursion first. For anyone listening, a geomagnetic excursion isn't a full pole flip, not north becoming south permanently.
Right.
It's more like the magnetic poles go on a major wander for a while. A temporary, but pretty dramatic shift.
And this specific one, Laschamps, was happening about 41,000 years ago. The study really points out, like you said, the North Pole wandered across Europe, but the crucial thing was what happened to Earth's shield, wasn't it?
That's the key takeaway. The magnetic field strength just tanked. It dropped way down to maybe only 10%, one-tenth of what it is today.
Wow, only 10%.
Yeah. And if you think about what that field does, it protects us from all that nasty radiation from space, from the sun.
Our planetary force field.
Exactly. So weakening it that much, that's a major event. It means a lot more harmful UV radiation could get through to the surface.
Okay, so the shield is down, way more UV light is hitting the ground, like leaving the door wide open.
Pretty much. And visually, one of the perhaps more stunning effects, which your sources mentioned, would have been the auroras, the northern lights. Normally, you only see them way up north, right?
Yeah.
But the study suggests that during Laschamps, you could have seen them across huge parts of the globe. Europe, maybe even parts of northern Africa.
Seeing the northern lights in, say, Spain or Italy, that would be incredible.
Mind-bending, yeah. Imagine looking up and seeing that shimmering curtain of light somewhere. It absolutely never appears now.
Okay, so we've got this picture. Weakened field, more UV, crazy auroras everywhere. Now let's bring in the humans. The study you shared suggests Homo sapiens might have had an edge because they were doing two things more often around this time: tailored clothing and using ochre.
Yes, and the archaeology seems to back this up, or at least correlate. You look at sites linked to Homo sapiens in Europe from that period, and you see, well, an uptick in certain tools, scrapers, for preparing hides,
Okay.
but also needles and awls, things you really need if you're going to sew fitted clothing. And that's different from what we typically find at Neanderthal sites from the same time.
So not just draping hides, but actual tailored gear, fitted clothes, better insulation, obviously.
Better insulation, definitely, which is huge in Ice Age Europe. But the study suggests it goes beyond just warmth. Being warmer means you can travel further, more efficiently, maybe follow herds or find resources.
Makes sense. Expand your range.
Yeah, exactly. But here's the kicker the researchers point out, that better clothing, covering more skin, would have also, maybe accidentally, provided better protection from the sun.
Ah. So they're making warmer clothes for the cold, but it inadvertently shields them from that extra UV radiation pouring in.
Precisely. That's a potential side benefit that suddenly becomes really important when the environment changes like that. Yeah. It could have given Homo sapiens a significant advantage, almost by chance.
Like accidental SPF clothing. Okay, what about the ochre? I know it's that reddish, earthy pigment. Iron oxide clay, people use it for cave paintings, body decoration.
Right. And again, the sources you highlighted show Homo sapiens seem to be using it more widely around the time of the Laschamps event. What's fascinating is the other property of ochre.
Which is?
Well, experiments and ethnographic studies looking at how modern groups use it suggest ochre actually has sunscreen properties. You mix it into a paste, put it on your skin, and it does offer some measurable UV protection.
No kidding. So they might have been using it for decoration or ritual, but it was also acting like a mineral sunscreen.
That's the hypothesis.
Yeah.
So picture this. You have Homo sapiens, maybe better dressed for the cold and inadvertently the sun, and possibly slathering on this natural pigment that also blocks UV rays right when UV levels are spiking.
That paints a pretty compelling picture, doesn't it?
Yeah.
Especially when you think about the Neanderthals.
It does. And then you look at the Neanderthals. The timing is, well, it's suggestive. They largely disappear from the archaeological record around 40,000 years ago.
Which is right around the time of this Laschamps event and this apparent increase in these protective behaviors among Homo sapiens.
Exactly. So the study you shared floats this idea. Maybe the lack of these specific adaptations, the tailored clothes, the consistent use of ochre as potential sunblock, maybe that left Neanderthals more vulnerable to the heightened UV stress.
So it could have been one factor pushing them towards extinction.
It could have been a contributing factor. It's really important to stress that. Neanderthal extinction was almost certainly complex. Multiple factors involved: climate change, competition, maybe disease.
Sure, it's never just one thing.
Never just one thing. But this study offers a new angle, right? It suggests how a specific environmental change, this weakened magnetic field, might have interacted with existing differences in technology or behavior between the two groups. It potentially tipped the scales.
I see. So it's putting known data together in a new way, looking at the correlation. The researchers aren't saying this is why Neanderthals disappeared.
No, definitely not. They're quite careful about that. It's correlational. They're looking at existing evidence through this specific lens of the Laschamps excursion and the UV impact. But it's a fresh perspective.
It highlights how something happening way out in space, the magnetic field, could directly impact survival down here, based on whether you had essentially the right gear.
Yeah, it really makes you think about how adaptations we might consider minor could become critical under specific pressures.
Okay, so we've looked back 41,000 years. But this research, the modeling they did, it's not just about the past, is it? There are implications for us now.
That's right. The 3D model they built to understand how Earth's geospace environment reacted back then. It helps us make better predictions about future geomagnetic events, weakening fields, excursions. They can happen again.
And if they do, what are the modern risks?
Well, think about how reliant we are on technology. A major geomagnetic storm, maybe triggered by a solar flare hitting a weakened field, could wreak havoc,
Like,
locking out communication satellites, disrupting GPS. It could even induce currents in ground-based systems, like power grids or long-distance communication lines. Think widespread blackouts, communication failures.
that sounds quite disruptive. A stark reminder that we're still vulnerable to these big space weather events.
We absolutely are. And understanding past events like Laschamps helps prepare, potentially. But there's another broader implication, too, mentioned in your sources.
Go on.
It relates to the search for life elsewhere. Astrobiology.
How so?
Well, the fact that life, including our ancestors, clearly survived and, in the case of Homo sapiens, maybe even thrived during a time when Earth's magnetic shield was significantly weaker.
Right, only 10% strength.
It suggests that maybe a super strong planetary magnetic field isn't an absolute must for life to exist on other planets.
Ah, that's interesting, because usually a magnetic field is seen as pretty crucial for habitability, for protecting an atmosphere and surface life from stellar radiation.
It certainly helps. But maybe it's not the deal breaker we sometimes assume. Perhaps life can find ways to cope, or maybe some planets without strong fields could still be viable habitats, depending on other factors. It widens the possibilities when we look at exoplanets.
So we shouldn't necessarily write off planets just because they have a weak magnetic field?
Perhaps not immediately, no. It adds another layer to how we think about planetary habitability.
Okay, so let's try and wrap this up for this deep dive. We had the Laschamps excursion about 41,000 years ago. Earth's magnetic field weakened dramatically. The poles wandered, and UV radiation likely increased significantly at the surface. And during this time, evidence suggests Homo sapiens were increasingly using tailored clothing and ochre. These behaviors, whether intentional or not, might have offered crucial protection against that UV spike.
And this might have given them a survival advantage compared to Neanderthals, who don't seem to show the same consistent use of these specific technologies, potentially contributing to the different outcomes for the two groups around that time.
It really drives home how adaptations that seem pretty simple, clothing and pigment use, can become incredibly important when the environment throws a curveball.
Absolutely. It's a great example of gene culture environment interaction, possibly.
Yeah. Which kind of leaves us with a final thought to chew on. If we look at this ancient example, how much do seemingly basic innovations or behaviors really matter for survival when the world changes rapidly, both way back then and maybe even now?
That's a great question. It makes you think about resilience and how sometimes the simplest advantages can cascade into really significant long-term consequences for a population's success.
Understanding Earth's dynamic past, these cosmic bumps in the road, and how life responded, it definitely gives us perspective on our own story, our future vulnerabilities, and maybe even our place in the wider universe.
Couldn't agree more. It connects the deep past to the present and even the search for life beyond Earth. Fascinating stuff.